Hi everyone. Let's take a look at number 13 on page 257. An isosceles triangle is inscribed in a circle of radius r. Find the value of angle theta that maximizes the area of the triangle. Before we start with step number 1, I'm going to take a step back to step number 0. If you think about the answer, if I have to make an educated guess, my guess would be the answer will be a triangle such that it has the most number of symmetry. So I'm thinking specifically an equilateral triangle. And again, if you think about this, an equilateral triangle has the most number of symmetry, and each angle is going to be 60 degrees. So my educated guess is that 2 theta equals to 60 degrees. Theta is going to be 30 degrees, or in radians, it's going to be pi divided by 6. So before solving this, which I will in a moment, my guess is the maximum area of the triangle occurs when angle theta is pi divided by 6. Step number 1, let's zoom in to this triangle. Based on the given, the radius is going to be capital R. So if I draw a line connecting it like that, that's going to be capital R. Same thing here, that's going to be capital R. These are the two radii. Since 2 theta is divided by half, this angle is going to be theta. This other angle is going to be theta because this is going to be an isosceles triangle. And of course, any triangle must add up to 180 degrees or adds up to pi. So this is going to be pi minus 2 theta. Now, if you think about a straight line, this is going to be 180 degrees, or it adds up to 2 pi, or I mean it adds up to pi. So this angle right here, it's going to be 2 theta. Again, this is basically pi minus 2 theta, which equals to 2 theta. So let's write that down, 2 theta. In fact, I'm going to erase all this. So now that you understand why it is 2 theta, I'm just going to write down 2 theta. Same thing here. Since you know all the angles add up to 180 degrees or adds up to pi, you can take pi minus pi divided by 2 minus 2 theta, which basically is going to be pi divided by 2 minus 2 theta. So I'm just going to write down the outcome. That angle is going to be pi divided by 2 minus 2 theta. Now, I'm going to draw two triangles underneath. I'm going to call these the equation of constraint. Now, here's the first one. Let's highlight this bottom triangle, which I'm going to draw right here. Now, again, a couple more things you want to think about. We know the height of this triangle can be denoted by h, and instead of calling the base b, I'm going to purposely call this b and call this other part b as well. So the entire base is going to be 2b, and this will all make sense in a moment. I'm just trying to make the math a little bit simpler. So let's go back to the triangle here. So again, this is going to be b. That's going to be capital R, which is the hypotenuse. This is going to be height h minus capital R. Again, let's make sure this makes sense to you. Notice how r is the distance from the top all the way to the center. So this measurement is the difference between the entire height, h, minus r. So the difference is h and r, h minus r, just like that. So again, if I go back, I can put in the other angles. This is going to be 2 theta, pi divided by 2 minus 2 theta. Now, I'm going to come back to this in a moment. The second triangle is right here. And again, let's draw this underneath. And we'll connect everything in a moment. So if I draw a second triangle, let me highlight the whole thing actually. I'm basically writing the following. So again, this is going to be angle theta. This is going to be the height, h, and b. Again, if you go back, b is at the bottom, angle theta is at the top, and height is basically the entire measurement. Again, I'm going to come back to this in a moment. Now let's write down the optimization statement. So we're trying to maximize the area of a triangle. And of course, if you think about this, the area of a triangle would have been base times height divided by 2. And in this case, it's going to be 2b, which is the base, times the height divided by 2. So again, the base is 2b, height is going to be h, and of course, divide this by 2. Now, one thing I didn't write, which I'll let you write on your own, is the let statement. So you can write down let r be the radius, let h be the height, let 2b be the base, and so on. Now in a different color, I can take 2 divided by 2. That's going to be 1. So again, I'm trying to make the mechanical steps a little bit simpler. Area equals to base times height. Now remember, the key here is to express area in terms of angle theta. So we're not trying to solve this in terms of expressing area in terms of base or area in terms of height. We're going to rewrite the whole thing in terms of angle theta. Now, here's how you can do this. One method is to go back to the first triangle and write down the following. If you think about SOHCAHTOA, again, be mindful. Sine is going to be opposite over hypotenuse. So when I think about sine 2 theta, that's going to be opposite over hypotenuse. So b divided by capital R. And of course, I can isolate for b by cross multiplying. So b is going to be r times sine 2 theta. And I'm going to plug it in a moment. Likewise, if I think about the second equation of constraint, I can go back and write down tan theta. Again, tan theta is opposite over adjacent. So in this case, it's going to be tan theta equal to b divided by h. Again, I can isolate for height. Height equals to b divided by tan theta. Again, we're going to plug it back in a moment. The moment is here. So b equals to r sine 2 theta, and I'll put brackets around 2 theta, times the height, which equals to b divided by tan theta. Now again, notice I can plug in b one more time. So a in terms of angle theta equals to, so I guess technically this is not in terms of theta yet. Let's go back and write down a. This is still just in terms of theta and in terms of b. So now I'm going to write down r times sine of 2 theta divided by tan theta. And again, b equals to r times sine of 2 theta. This means, again, let's zoom in for you, a is now in terms of theta, which equals to r squared times sine of 2 theta, quantity square, divided by tan theta. We're now ready to find the derivative, set it to 0, solve for theta, and plug it back in. And if you watch all the way to the end of this video, I'm going to show you how to double check by verifying that this is really the maximum by going through the second derivative test. Here we go. Step number 1, I'm going to find the derivative. Now notice I could use the quotient rule, but instead I'm going to rewrite this first in a different form. So I'm going to keep r squared as is. If I think about sine 2 theta, that's really 2 sine theta cosine theta in brackets square. If I look at the denominator, tan theta is going to be sine theta over cosine theta. So what I'm trying to do here is I'm trying to simplify this before finding the derivative. Again, if I expand the top, that's going to be r squared times 4 times sine squared theta times cos squared theta. And I'm going to multiply by the reciprocal. Again, when there's a fraction divided by second fraction, I can take the first fraction and multiply by the reciprocal of the second one. Now, again, in a different color, I'm crossing out one sine theta from the bottom and one from the top, which means A in terms of theta equals to 4r squared times sine theta times cosine theta to the power of 3. I'm now ready to find the derivative. A prime equals to, now I'm going to apply the product rule here. So again, just to make sure no one's left behind, I'm expressing this as the first part and this as the second part. So I'm going to differentiate the first. That equals to 4r squared times cosine theta. Step 2, copy the second part, cosine theta to the power of 3, plus copy the first part, 4r squared sine theta times the derivative of the second part. Again, don't forget the chain rule. So you bring the 3 to the front, copy cosine theta to the power of 2 times the derivative of cosine theta, which is negative sine theta. I'm now ready to set this to 0 and solve for theta. First, I'm going to collect like terms. 4r squared times cosine theta to the power of 4 minus 4 times 3 is going to be 12 r squared times sine squared theta times cos squared theta. 0 equals to, I take a common factor of 4r squared times cosine square theta to the front. In brackets, there's still another cosine theta square minus 3 times sine square theta. I'm going to divide this into 2 different columns and solve for theta. Be mindful, as I'm solving for this, I'm also thinking about the restriction. Just because you can find angle theta, it doesn't mean that is the actual answer. So for example, in the first column, I can already see in my mind that this answer is not going to work. It's going to be rejected or omitted. So again, the opposite of multiplying by 4r squared is to divide by 4r squared. So cosine squared theta is going to be 0. The opposite of taking the square of cosine theta is to find the square root. And cosine theta is going to be 0. Now again, some answers include theta equals to pi divided by 2, 3 pi divided by 2, and so on. And again, in case you're thinking, how do I know this? I'm thinking about the cosine graph. So these values right here are right there, right? So pi over 2 and 3 pi over 2. You could take a calculator in radian mode, that works as well. But here's the issue. When you think about the restriction, we know angle theta must be an acute angle. So theta or 2 theta, we're expecting to be in between 0 and pi divided by 2. Or if you want to divide everything by 2, you could say theta is going to be in between 0 and pi divided by 4. So the fact that pi over 2 and 3 pi over 2 is not part of the domain, these answers will be omitted or rejected because of the domain. Now, in the second column, look what happens. Cosine theta squared minus 3 sine theta squared equals to 0. I can bring negative 3 sine theta squared to the right, divide both sides by cosine theta squared. This means 1 equals to 3 tan theta squared. I can also divide everything by 3. This means, and I'll zoom in for you, that tan theta squared equals to 1 divided by 3. Again, when you think about the opposite of squaring something, you take the square root. There are 2 cases. However, when you think about tan theta, which equals to positive 1 divided by root 3, or when you think about the second case, tan theta, which equals a -1 divided by root 3, you may be thinking about the following. So in the first case, you may be thinking tan theta is positive, has to be in quadrant number 1, quadrant number 3. Then in the second case, where tan theta is negative, you may be thinking about the second and the fourth quadrant, but remember the restriction. 2 theta must be an acute angle. So if you really go back and you think about the basics, we know tan theta is going to be opposite over adjacent. So opposite over adjacent, that's the special triangle with the hypotenuse of 2. And this angle is going to be pi divided by 6. And technically, you can write down pi over 3. So the only answer that's going to work is going to be theta, which equals to pi divided by 6. So again, all other answers are omitted or rejected. And again, you can write down a final statement. Therefore, angle theta, which is pi divided by 6, will maximize the area of the triangle. And that could be your final statement. Now again, I would like to over-deliver. Let's double check this by going through the second derivative test. So in a different color, this is the bonus part I would like to offer you. Again, if you go through the second derivative test, we're going to verify that this critical point really is the maximum. So again, we go back and we copy a prime of theta, which equals to 4r squared cosine theta squared times, in brackets, cosine theta squared minus 3 sine theta squared. We're going to find the second derivative, a double prime, and we're going to plug in the critical point, pi divided by 6. Again, let's put some brackets around the first term. I'm going to apply the product rule. So step 1, I'm going to take the derivative of 4r squared cosine theta squared. That's going to be 2 times 4r squared, so 8r squared times cosine theta times negative sine theta. Step 2, copy the second part, plus step 3, copy the first part, and multiply by the derivative of the second part. Again, when you take the derivative of cosine theta squared, that's going to be 2 cosine theta times negative sine theta minus 6 times sine theta times cosine theta. Now at this point, you're going to plug in the critical point, pi divided by 6. If we are doing it right, we're going to find a negative value in terms of r squared. So I'm going to take my calculator. I'm going to try this with you. So all I'm doing is I'm going to plug in pi divided by 6. You don't have to collect like terms. You don't have to simplify this. You just got to work it out. Again, make sure if you have a calculator standing by, it's turned on, you press clear, and it's in radian mode. So I'm just going to copy everything else, replacing theta with pi divided by 6. Okay, take your calculator. I'm going to do this with you right now. So again, I turn it on and press clear. I'm in radiant mode. Now don't worry about the r squared because you can express this in terms of r squared. So 8 times cosine of pi divided by 6 times negative sine of pi divided by 6 times in brackets cosine pi divided by 6 square minus 3 times sine of pi divided by 6 square. Now the first part, by the way, becomes 0. So this entire first part, you work it out, it's going to be 0. Let's keep going. In the second part, I'm going to press 4 times cosine of pi divided by 6 square times, in brackets, 2 times cosine of pi divided by 6 times negative sine of pi divided by 6 and I'm going to keep going. When I work it out, this is approximately negative 10.39230,485 times r squared, which basically means it's going to be a negative outcome. The fact that it's negative, this means it's going to be concave down, which implies it's going to be a maximum. I hope this makes sense.